Welcome back. This is Weblan. I want us to look at Euclidean geometry. This question is grade 11, November 2018. We are going to look at question 9, 10, 11. Someone requested that I explain a few of the questions, but I'll just do the whole section of Euclidean geometry, starting with question number 9, 9.1. In the figure O is the center of the circle. A, B, C, D, and E lie on the circle such that chord AB and chord DC are equal. This is chord AB and this is chord DC. They are equal in length, and AEB is 39 degrees. This is AEB is 39 degrees. And then looking at the questions, determine the size of O1. O1 is here. O1 here is equal to 2 times 39. This is 2 times 39. That is 78 degrees. The reason for that, it's subtended here. So this is angle at center is equal to 2 times angle at circumference. This is the angle at the center, which is 2 times bigger than angle at the circumference. That is the first one, O1. And then the second one, determine the size of O2. Here is O2. We were told that AB is equal to DC. These are chords. So if these two chords are equal, and you should notice that this is radius, 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 radius. So these two triangles, they are identical here. They are congruent, right? Now, we can say that your O2 is equal to your O1, and that is equal to 78 degrees. The reason for that, equal chords subtend equal angles. The two angles are subtended by equal chords there. That is question 9.1. Let's go to 9.2. In the diagram, S is the center of the circle, PQRT, and then PT is diameter. This is PT, it is a diameter. RST, where's my R? RST, this angle here is equal to X minus 8 degrees. And then PQR is equal to 2X minus 40. Here's our 2X minus 40. And then for this diagram, you are supposed to determine the value of X. And you should always give reasons in Euclidean geometry. How do you do that? I'm seeing two ways of doing this. The first one here, we can include the constructing chord RT here. If we construct chord RT, we can get this angle here. We have a cyclic quadrilateral PQRT. That's a cyclic quadrilateral. So this angle here is opposite that angle. So we are saying angle T here is equal to 180 minus 2x minus 40. Put it in bracket. 180 minus 2x minus 40. What do we get there? This is going to be equal to 180 minus 40, that's 220 minus 2x. And reason for that, opposite angles of cyclic quad. That is the reason for this angle. Now we have this triangle here. This triangle is an isosceles triangle because SR, ST, that's a red there. So to get the value of x, we can just add all the three angles there. And we know that when we add interior angles of a triangle, we get 180. And then before we do that, we should declare that this angle here, SRT, is equal to T there, and that is equal to 220 minus 2x. The reason for that, opposite, is angles opposite equal sides. That is the reason for the isosceles triangle. Now the three angles here, we are now saying the angle at S plus the angle at R plus the angle at T, that is equal to 180 degrees. Those three angles we have x minus 8, that is the angle at S, and then plus the angle at R here, which we said is equal to T, that is 220 minus 2x, and then plus 220 once again, 220 minus 2x. These three will give us 180 degrees. The reason for that, angle sum of triangle. And then let's solve for x in this thing. We have x minus 2x minus 2x, and that is minus 3x there, minus 3x. We have 220 plus 220, that is 440 minus 8, that is plus 432, and that is equal to 180. And we say the reason, it's some angle sum of a triangle, or interior angles of a triangle. And then solve for x here. You can take your 3x to the right, and then your 432 to the left. I mean your 180 to the left. So we have 432 minus 180 there is equal to 3x. And then 432 minus 80, 432 minus 180, that is 252, and then we'll have to divide both sides by 3 here. So this is divide by 3, what do we get is 84. So your x here is equal to 84 degrees. This is sorry, one of the ways through which you could have done this. Another way, which probably is shorter, you should notice that this is a straight line. So we have a straight angle here, which is 180 degrees here. So we have angle at the circumference and this angle at the center here. This is the angle at the center there. So this angle at the center is 2 times bigger than the angle at the circumference. This is going to give us, we are saying, the angle at the center, 180 plus x minus 8 there, is equal to 2 times the angle at the circumference. This is 2x minus 40 there. Now, in this expression, you will have to solve for x, but give the reason first. Angle at center is equal to 2 times angle at circumference. And then clear the bracket first. We have 180 plus x minus 8 is equal to 4x minus 80 degrees there. and then take your x to the right and then your 80 to the left. We have 180 minus 8 minus, okay, this is plus 80 because it is positive there, and this is going to be equal to 4x minus x. And then we need to solve for x in this. So we have 180 plus 80, that is 260, 260 minus 8, that is 252 is equal to, this gives us 3x, and then divide by 3, divide by 3, your x there is equal to 84 degrees. So these two methods we're going to give you the same answer. That is the first question there. And then going to the second question, 9.3. In the diagram, O is the center of the circle. O is the center of the circle. In the diagram, O is the center of the circle. Chord AC is perpendicular to radius OD at B. OB is 2x units and AC is 8x units. All right. This is what we have here. From what we were given in the diagram, AC is perpendicular to this radius, and then OB is 2x. Let's write the 2x there. This is our 2x. And then AC is equal to 8 units. This is our AC, and we see that AC is perpendicular to the line from the center. There, you remember the very first theorem. So the very first theorem tells us that this line from the center, if it is perpendicular to a chord, then it bisects the chord. So that tells us that this is 4x and this is 4x. We need to write it down there. So we are saying AB is equal to BC, and that is equal to 8x divided by 2, that is 4x. And reason for that, line from the center perpendicular to chord, line from center perpendicular to chord. So you should notice that we now have a triangle that has this side and this side, and we can look for the hypotenuse. All right. Now, what is the question telling us to do? Show that the length of BD is equal to this. Here is our BD. We do not have a way of directly calculating the length of BD, but we can calculate the length of OD here, and OD is radius. So you should notice that AO is equal to AC, and that is equal to OD. That is the reason. And then we can use this triangle, we can use that triangle to calculate the length of the radius. So we are saying your OC is equal to the square root of, this is OC, our hypotenuse, the square root of 4x squared plus 2x squared, that is under the square root there, and this is going to give you 16x squared plus 4x squared, and that gives you the square root of 20x squared. Let's simplify this one. 20 is equal to 4 times 5, and the 4 will go out as a 2. 5 is left inside this. This is squared. It also goes out because you can get the square root of x squared. So this simplifies to 2x multiplied by the square root of 5. And then we now have OD, because we said here OD is equal to OA. So we are saying this is equal to OD. Now how do we get BD? BD is equal to OD minus OB. This is our BD, the one we are looking for. So it's a matter of saying OD minus BD. We do have our OD. Our OD is 2x square root of 5 minus OB is a 2x. There we are. And then the very last thing, just factor out 2x. So we have 2x bracket square root of 5 minus 1. And it has been shown. There we are. That is question number 9.3. And then let's go to the next one. Question number 10. This one should not be difficult. It's one of the proofs. This is 5 marks there. We need to prove the fact that required to prove the fact that P plus X, P plus S is equal to 180, or R plus T is equal to 180 degrees. That is what we are required to prove, and we are given the circle with a cyclic quadrilateral PTSR inside with center O. So how do we prove that? Let's prove this one. P plus S is equal to 180 degrees. We make use of that theorem which says angle at the center is equal to 2 times the angle at the circumference. So the first step is construction. Construct or join RO and also join TO. This is ready. So here we are. This is RO, and then we have TO. And then from there, we have O1 on this side, we have O2 on this side, and let P be equal to X and S be equal to Y. So this is your X and this is your Y. And from what we have in the diagram, we know that your O1 is equal to, this is our O1 here on top, it's equal to 2Y. And O2 is equal to, this is your O2 down here, is equal to 2x. And reason for that, angle at center is equal to 2 times angle at circumference. That is the reason for that. Now we have two things that we have to deal with. The first one, we said O1 is equal to 2y, and then O2 is equal to 2x. Now, we need to put these things together. So we are saying 2y plus 2x. The right side here, 2y plus 2x, is going to be equal to O1 plus O2. What do we get when you add these two angles here? We get a complete revolution there. So this is going to be equal to 360 degrees. That is a complete revolution there. And then 2y plus 2x, factor out a 2 there. We have 2 bracket. I can start with x and then a y. Remember, addition is commutative, né? And then divide both sides by 2, divide by 2, and these will cancel each other. So your x plus your y is equal to 180 degrees, and that is what we wanted to show here. So we are saying therefore P plus S is equal to 180 degrees. They are supplementary, and that is what you were supposed to prove. And then the next question, this one looks more interesting. In the figure, we have SP, SP. In the figure, we have SQ, is SQ. We have SQ and PR being diameters of the circle center O such that PQ is parallel to SR. PQ here is parallel to SR, and then PS is produced. This PS is produced to T. N is a point, where is N? Here is N. N is a point on the circle such that Q1 is equal to Q2. So we have Q1 is equal to Q2. That is what we've been given. And SN is drawn. Where is SN? We have SN here. SN is drawn. RS intersects. Where is RS? This is RS. RS intersects QN at M, and then S1. There is S1 is 48 degrees. So this is S1, S2, S3, S4. Please take note of the fact that this is not a tangent. So we do not have a tangent in this diagram. All right. Now, what is the question requiring us to do? Determine with reasons the sizes of the following. The first one is Q1. How big is Q1? All right. For Q1, we have cyclic quadrilateral PQNS. And we have this angle here. This is an external angle of a cyclic quadrilateral. It is equal to the opposite interior angle of a cyclic quadrilateral. So we are saying here S1 is equal to NQP. And reason for that, this is external angle of a cyclic quadrilateral. So we are saying this is equal to 48 degrees. So this whole thing is 48 degrees. And we were told here that Q1 is equal to Q2. So therefore we are saying Q1 and Q2, they are both equal to 48 divided by 2, that is 24. This is equal to 24 degrees, and we should take note of the fact that QS bisects the angle there, the whole angle at Q. And then the next question is R. Where is R? Here is R here. How big is R? R is the same as Q1. R is equal to Q1, and this is equal to 24 degrees. These two angles are subtended by this chord. They are subtended by the chord PS, both of them. That is R1 and Q1. So this is equal to 24 angles in same segment. All right. And then from there we want M1. Where is M1? This is M1. How big is M1? Okay, make it a little small. I want to clear this part. M1 is equal to what? There's two ways to get M1 here. There's two ways to get M1. The first one, we have parallel lines. This line is parallel to this line. And then we have QN as a transversal, right? So because we have parallel lines, then these two angles here, they are supposed to be equal. So M1 is equal to 48. M1 is equal to NQP, né? NQP, and that is equal to 48 degrees. And reason for that, corresponding angles with the parallel lines, RS being parallel to QP. Remember, whenever you state anything on fun, anything that is created by parallel lines, you need to state the parallel lines. So M1 is 48 degrees. And then another method that you could have used, we said this is 24 here, right? And then this is 24. So we are saying Q1, your Q1 there is equal to S3, and that is equal to 24. Reason for that, alternating angles with PQ parallel to RS. So if this is 24, we have a triangle here, triangle QSM. In triangle QSM, this and that, they equal to 48. So in triangle QSM, M1 is equal to 48. That is Q1 plus S3. And reason for that, that will be external angle of triangle. We are saying this one here is equal to, this one here plus this one, they give us this external angle of a triangle. That is 48 degrees. That is another method that you could have used there. And then prove that ST is a tangent to the circle passing through MNS. This is MNS. So it is saying ST here is a tangent. Let me draw the diagram aside. I have a circle. My circle is not so perfect. And then I have my N here. It is saying we have an M, and then it goes there. And then this part, we started with it being 48 degrees there. And then this one, M1, we saw that M1 here is 48 degrees, right? So which theorem do you see there? This angle here being equal to that angle. That is, if the circle MNS here has a tangent ST, these two angles are equal. So we are saying here M1 is equal to S1, and that is equal to 48 degrees. The theorem there, that's converse of tan chord theorem. That is the converse of tan chord theorem. And that proves that ST, we have our S, our T here. So that proves that ST is the tangent to this circle that has a triangle inside with MS. All right. Let's go to the last question. In this question, we are told that O is the center of a large circle. Here is our O. And then OP is diameter. This is OP is the diameter for this smaller circle. And then NP is a tangent. NP is the tangent to both of these two circles. the big one and the smaller one, and we have Rn perpendicular to NP, Rn perpendicular to NP, and then let P1 be equal to X. Here is our P1, here it is equal to X. These questions you are supposed to prove. How do we prove this? Prove that PR bisects ORN. Where is our PR here? This is our PR. It bisects ORN, right? So it bisects this angle. Now, what shows us that it bisects? For it to be bisecting, then your R1 should be equal to your R2. This angle here should be equal to that angle. If this is bisecting, that is, if it is cutting it into half. Now, let's see if we can determine the sizes of these angles. R1 here, your R1 is equal to, this is a right angled triangle. With this one, it's X, and this one is 90 degrees. So R1 is 180 minus 90 minus X, and that gives us 90 minus X. That is the size for that one. Reason, angle sum of a triangle, that is R1. Now we need to determine the size of R2 here. Let's write it in terms of X. Looking at our diagram here, I see this is X here. So we are saying T1 is equal to X, and this is Tancourt theorem. Right? This is X, T1 is equal to X, that is Tancourt theorem. And then from there, we have the angle at the center. Remember, O is the center, and O1 and T1, both of them are subtended by this chord RP. So this angle here is 2 times bigger than that angle. So we are saying from there, Q1 is equal to 2x, and the reason for that, angle at center is equal to 2 times angle at circumference. So we now have that this is 2x, right? Now, if this is 2x, how big is this one and that one? Remember, this is radius and this is radius. So we have an isosceles triangle here. Ne? So to get that, we can just say, okay, let's first declare that is an isosceles triangle. So we are saying RO is equal to PO, and that is radius. And then from there, it follows that R2 is equal to P2, and this is angles opposite equal sides. So now to get the size of this one and that one, we are now saying your R2 is equal to 180 minus 2x, and we divide that by 2. Remember, this angle and that angle, they are equal, and reason for that is angle sum of a triangle, angle sum of triangle. So this is going to be 2 into 180, it's a 90 minus x. Remember where we started from? We started from this one. We said R1 is equal to 90 minus x, when we have seen that R2 is also equal to 90 minus x. So from there, we are saying R1 is equal to R2. Therefore, PR bisects that ORN. So what you were supposed to do here was just to determine the size of angle R1, and then you determine the size of angle R2. All right, I see another method that you could have used, which probably is even shorter. Here is what I see there. Let me just clear what I had written there. Yeah, let's clear this. And we are redoing that first question there. All right, this is what you should remember. We have, this is a tangent and this is diameter. And when a tangent meets a diameter or radius, they create 90 degrees, right? So we are saying here, NPO is equal to 90 degrees. And we are saying tangent perpendicular to radius, or you can say perpendicular to diameter there. Now, if this is 90 degrees and this is x, so we are saying P2 is equal to 90 minus x. Remember, this is x and this whole angle is a 90-degree angle. So to get this one, we subtract this x, we have 90 minus x. And then from there, we are saying PO is equal to RO, that is radius. PO and RO. With this one, we are confirming that we are declaring that it's an isosceles triangle, and it follows that P2 is equal to R2, and that is equal to 90 minus x. And reason for that, reason for declaring that these two angles are equal, this is angles opposite equal sides. So we now have the first one there, that is R2, and then R1, you're going to make use of this right angled triangle. This is 90, this is x. To get this one is 180 minus 90 minus x, and that gives you R1 is equal to 90 minus x. And reason for that, angle sum of triangle. And the conclusion there, R2 is equal to, the conclusion, R2 is equal to R1. If R1 and R2 are equal, then it confirms that RP bisects that angle. That is the first question with 5 marks. And then the second question, ROS is equal to, is our RAO? This is ROS. This is equal to PAT. So we are talking about these two angles. This is the first one, and this is the second one. We need to determine the sizes of those two angles. Remember, we said this one is 90. Let me clear a little bit here. We determined that this is 90 minus x there. And then we have a cyclic quadrilateral, and opposite angles of a cyclic quadrilateral, they are supplementary. So we can determine the size of this angle here because it's opposite to this one. So this one is going to be your, let me just call it A. Your A is 180 minus, in bracket, 90 minus x there. And this is equal to 180 minus 90. It's a 90 minus x. It's a plus x. So we are saying this one is 90 plus x. Reason for that, opposite angles of cyclic quad. That is our reason there. Now after this one, we need to determine the size of this one here. Remember, we already know that this is 2x, so we just have to determine O2. How do we determine O2? Remember, OP here is diameter, and we have an angle in the, we have an angle in a semicircle here. We have an angle in the semicircle, and also we have an x here, and then we have OT and OP, their radius. So we are saying P3 is equal to T1, and that is equal to x. And this is angles opposite equal sides. So this is x equal to this one because it's an isosceles triangle. And then we also stated that S1 is equal to 90 degrees, and the reason for that, angle in a semicircle. So this is 90 here. If this is x and this is 90, how do we get Q2? Your Q2 here is 180 minus 90 minus x. 180 minus 90 minus x, that is 90 minus x, right? So this is 90 minus x. Now the angle that we are interested in, the angle ROS, is equal to Q1 plus Q2. This is Q1 plus Q2, and this is 2x plus 90 minus x. Q2 is 90 minus x there, and this is equal to what? This is 90 plus x. Now we have the sizes of the two angles that we want. This one here, this one here, I need to make it a little bigger. So we are saying the angle here, this one here is 90 minus x. That's the first one, and this is 90 minus x. So we are saying from what we have seen there, this is equal to that, and that is equal to 90 minus x from what we determined there. That's all you were supposed to prove, to show that both of them, they're equal to 90 minus x. All right, that's all I have for you now, and that's Euclidean geometry. Remember, practice makes